Good day, students. Welcome to Mathgotserved.com. And this clip, we're going to be going over problems 25 to 30 of the January 2017 Geometry Regents Common Core Release Exam questions. All right, let's take a look at question 25. It reads, using a compass and a straight edge, construct the line of reflection over which triangle RST reflects onto triangle R prime S prime T prime. Leave all construction marks. Okay, so we have triangle RST and triangle R prime S prime T prime. And the result of this image is by reflecting triangle RST over a line. So we want to construct that line that enables this reflection to happen. Okay, so all we have to do is to construct a perpendicular bisector of a line segment connecting any two points that are a reflection of each other. Okay, so we're going to pick points R and R prime. Okay, so we are going to first of all draw a line segment from R prime to R, and then what we're going to do is, so our approach is going to be, we're going to construct a perpendicular bisector of the segment we just created, which is segment R prime. Okay, so if we construct that perpendicular bisector, that line will be the line of reflection over which we can have this reflection happening. Okay, all right, so let's go ahead and simply bisect that line. We're going to be using the same approach that we use for bisecting line segments. That's what we're going to be using here. All right, so what we'll do is draw an arc by actually two arcs by placing the endpoint of your compass at the 2 points. Okay, so let's draw the first set of arcs. So I'll place it right here. Let me scroll down a little bit. It doesn't really matter how far you stretch your compass. You just want to make sure that the arcs you create are within range. Okay, so we have that right there. So I'm going to draw an arc on where I expect the intersection to be. Okay, so make an arc right there, and then let's rotate my compass all the way over there and make another arc. Now what we're going to do is move the tip of our compass to the other end, point R prime, which is the reflection of R, and then we're going to make another set of arcs again. Okay, so I'm going to make an arc right here, and then over here, oh, sorry, let's fix that, and then so we're going to draw the next arc at the other end. So I'll just rotate this down to that end, and then I'll draw my other arc. Okay, so the line going through the intersection of these two arcs is the reflection line that we need. All right, so let's go ahead and draw that line. So that line right there is the reflection line that we are asked to construct. Okay, so let's give it a name. Let's call it line L. So call this line L. So conclusion, line L is the line of reflection over which RST reflects onto R prime, S prime, T prime. All right, so that's that. All right, let's take a look at 26. Is another question on transformation. It reads, the graph below shows triangle ABC. So on the right side we have triangle ABC, and then on its image a double prime, b double prime, c double prime. Okay, the double prime tells us that we have two transformations, a composite transformation. Question: describe a sequence of rigid motions which would map a triangle ABC onto triangle A prime, triangle A double prime, B double prime, and C double prime. Okay? Alright, so how do we do this? Now, what we can do is, let's first of all focus our attention on just one point. Okay? Let's focus on the C's. How can we get from C, this C right here, to this C double prime right there? First thing you'll notice is that we have an equal distance between C and C double prime and the and the y-axis. Okay, so C is 2 units from the y-axis here. C double prime is 2 units away from the y-axis. So what does that indicate to us? There's a great possibility that we have a reflection about the y-axis. And guess what? That is the case. Okay? So if you reflect point C about the y-axis, you're going to end up right above C double prime. That will be C prime. So the first transformation, let's write that down. The first transformation is going to be a reflection over the y-axis. Reflection over the y-axis. Alright, so can you visualize what the second transformation is going to be? The second transformation simply involves shifting C 2 units down. Okay, when you shift it 2 units down, then now you end up with C double prime. Alright, so let's write this down. The second transformation will be to shift 2 units down. Alright, so this is the sequence of transformations that will give us A double prime, B double prime, C double prime. There's another way that we can write it. Okay, so if you reflect about the y-axis, this can be written as R sub y-axis, a reflection about the y-axis. If you shift 2 units down, that's a translation. You're not going left or right, so you have 0 for the y. For the x, remember horizontal movement is the x. And then since you move 2 units down, that will be -2 for the y component of the translation. Okay, so this is one way of writing it. One way. Or let's just call it method 1 or form 1. And then another way you can write it is using your transformation notation, which is the one that goes last is what we write first. Okay, so the last one was the translation. So we have translation, no translation left right, but 2 units down is the last one. But before you do the shift, you do a reflection. So this compose means you're composing that with a reflection about the y-axis. So R sub y-axis is the second, or is the first transformation you do before you do the translation. Okay, so these are the 2 different ways you can express the sequence of transformations that will result in A double prime, B double prime, C double prime. Alright, let's take a look at problem number 27. It reads, when instructed to find the length of HJ, so we want to find this length right here, in the right triangle HJG, Alex wrote the equation sine 28 degrees equals HJ over 20, while Marlene wrote cosine 62 equals HJ over 20. Are both students' equations correct? Explain. Alright, so we have 62 and 28 here. Let's take a look at this triangle for a second. If angle G is 28 and this is 90 degrees, then what must angle H be? These 2 angles are complements of each other. Okay, so this has to be um, you subtract 28 from 90 to get angle H. Or another way we can write it is we can say angle H plus G. Let's write it this way. Measure of angle H plus measure of angle G plus measure of angle J is what? 180. That's the sum of angles in a triangle, right? So measure of angle H is going to be measure of angle G, which is 28, plus measure of angle J, which is 90, equals 180. If you subtract 28 and 90 from both sides, you end up with measure of angle H being equal to 62 degrees. Alright, so this right here is 62 degrees. So the question is, who is correct? These two angles are complementary angles, okay? And we have a special identity known as the cofunction identities that's related to complementary angles. So let's write down the answer to the question. Since 28 degrees and 62 degrees, the angular measures that both selected, since they add up to 90, add up to 90 degrees, they are what? They are complementary angles. Okay? And then, what else can we state? And we also know that since sine and cosine, since sine and cosine are cofunctions, what does it mean for sine and cosine to be cofunctions? Basically, that the sine of an angle is equal to the cosine of the complement of that angle. Okay? Since we have this condition, it follows that sine 28 degrees, which is equal to hj over 20 is equal to cosine of the complement of 28, which is 62 degrees. Okay? So what does that help us conclude? This implies that who is correct based on this equation? It implies that Alex and Marlene, they are both correct. Okay? Alex and Marlene are both correct. All right, let's take a look at question number 28. It reads, in the diagram below, tangent DA and secant DBC are drawn to circle O from the external point D, such that arc AC is congruent to arc BC. Question, if the measure of arc BC is equal to 152 degrees, determine and state the measure of angle D. Alright, so we want to find this angle right here. Now, let's go ahead and write down the formula that is going to guide our problem solving process. Alright, so the measure of angle D is 1/2 the measure of the bigger arc of the circle that this secant line cuts out. So the measure of arc AC minus the smaller one, which is measure of arc AB. Alright, so this one and this one are the two arcs that we're looking at. Alright, so let's go ahead and determine the needed components to find the measure of angle D. Let's start with measure of arc AC. Let's see, what do we know here? We know that AC, arc AC is congruent to arc BC, right? So if the measure of arc BC is equal to 152 degrees, then what? Then the measure of AC is also going to be 152 degrees also, because the angles are congruent. All right, so we have one piece down. That's 152. What's the measure of arc AB? Now we know that BC is 152. AC is also 152. Can we determine what the measure of arc AB is? And the answer is yes. Remember, the sum of angles around the circle is 360, right? So the measure of arc AB is going to be equal to the entire circle, which is 360, minus the sum of these two angles here, 152 plus 152. Okay, and then when you work it out, you have 360 minus 152 times 2. Let's put that in a calculator. So 152 times 2. So 304. And then when you subtract 304 from 360, you get the measure of arc AB equal to, let's see, so 56 degrees. Okay? All right, so we want to find a measure of angle D. We now have measure of arc AB is 56, and AC is, what is AC again? Measure of arc AC is 152. Okay, we stated it right here. So we have the two ingredients we need. All right, so let's finish this off. Measure of angle D is equal to 1/2. Let's write down the formula again, just to make sure we don't get confused here. Measure of arc AC minus measure of arc AB. Okay, so we're going to substitute the values we just calculated. Measure of arc AC is 152 minus measure of arc AB is 56. Let's have our calculator do the heavy lifting here. So we're going to compute the half of the difference. So we have 152 minus 56. Divide that by 2. And you get 48. So measure of angle D is 48 degrees. All right, let's take a look at question number 29. It reads, in the diagram below, segment GI is parallel to NT, and segment IN intersects segment GT at A. Okay, so GI is parallel to NT. Question, prove that triangle GIA is similar to triangle TNA. All right, so let's go ahead and we're going to use a two-column proof format for this. So we're going to have our statement and our reasons. Okay, now we're trying to prove similarity here. So let's start by writing down some of the things that we're given. All right, so first of all, we know that segment GI is parallel to segment NT, and we also have two transversals, GT and IN. Okay, so NGT, segment GT and IN are transversals. All right, so this is given to us. All right, next. Now, if you have two parallel lines and two transversals, what you'll have is you can create alternate interior angles. Okay, so angle I and angle N are alternate interior angles. Okay, and angle G and angle T are alternate interior angles. If two parallel lines are cut by a transversal, what do we know about alternate interior angles? They are congruent. Okay, so we can easily conclude that angle T is congruent to angle G, and angle I is congruent to angle N. What's the reason? It is because um, parallel lines cut by a transversal form what? They form, one of the things they form out of the many is alternate interior angles. Okay? They form alternate interior angles that are what? That are congruent. That are congruent. Okay, so we have two corresponding angles in two triangles that are congruent. So if you have two triangles and two corresponding angles are congruent, what can you conclude? You can conclude for a certainty that those two triangles are similar. Okay, so triangle GIA is similar to triangle TNA. How do we know that? This is by the angle similarity postulates. The angle similarity postulates. Okay? So that is the end of our proof. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel, and more clips, tutorials, tips, tricks, and formulas can be found on Mathgotserved.com, so visit it. Thanks again for watching and have a wonderful day. Goodbye.